Today is December 8, 2021. I want to compare the IT industry last-minute change with certain situation to respect the platform policy and also get this video published. I'll try avoid using certain words. I'll just say the liquid in the arm, but I think everyone knows what I'm talking about. I'll share my decision. Basically, I do not consent, and share my thinking process. First, I'll talk about the software development life cycle, SDLC. So the software development is started with a requirement gathering, so we know what the people want. And then the analysis and the design to analyze the requirement to have a solution. And then implementation, this one is about developing the code. And then the testing all the features. And then deployment, basically go to production so everyone can use it. And the testing, there are several types of testing. One is the unit testing. Basically, we're testing the new function, the change function, see if it's working as designed as required. And then the system integration testing. This one, we are doing an end-to-end system testing, testing all the features, testing all the scenarios. And then the regression testing. Because the system is not used by only one people, it's used by multiple users, many peoples. So we need to test multiple users and then do the performance analysis, performance testing, etc. And then in IT, we have this term, last-minute change. I think this happens in some other industries as well. So what happens is that after testing is done, it's ready to go to production, we have a code freeze. At this time, no one allowed to do any change. But at this time, there are sometimes new requirements comes in, or there are some other situation. We have to change the code, but we don't have enough time to do a full testing. At this time, we have to still do the requirement analysis and the design, and do the implementation. And after the change is done, we can do the unit testing the new function, etc. This one is complete, otherwise we are not ready. And then we'll do the system integration testing. Depends on the timing, how much time we have. We may only able to test only certain scenarios. We may not able to test all the scenarios. And then the regression testing, because we don't have time, we have to skip that. It's not complete. So this last-minute change, we are trying to avoid that because it is high risk, very risky. But it happens. It happens. We cannot avoid it. So we need to accept that. But to deploy this last-minute change, we need special approval. We call exception approval, so that we can deploy it to production. This approval process is different than the normal process. For example, people need to recognize the risk, etc. And then in IT, we also have this risk management and risk mitigation plan. So we need to identify, classify, and mitigate the risk throughout the project lifecycle. So this is a big topic, but here we only talk about the last-minute change. So we'll talk about the last-minute change risk mitigation. So one thing we are trying to do is that we need to reduce the scope so that we can reduce the impact. For example, we are hijacking the deployment file, so only deploy 1 or 2 changed files. Using our Java year file deployment as an example. We deploy one year file. This year file is actually a zip file. Within it, it has hundreds or even thousands of files. So, but one normal deployment, we build the whole thing. So means hundreds of thousands of files. All of them are changed. But in this last-minute change scenario, we only change 1 or 2 files, and all the other files stay exactly the same as before. It is a manual process. That's the reason we call it hijack deployment file. So our assumption is that in the worst case scenario, there are problems in this last-minute change code. And unfortunately, we couldn't identify that during our testing. We only found out that in the production, after it goes to production, after people are using it. But the problem itself is only in the area where the original defect, where the original requirement comes from. So other system functions, they are not affected. So it is relatively easy to fix the problem and caused by the last-minute change. That's our assumption. So there's other IT terms. One is the architectural decision. So basically, architectural decision. So during the project, we have different stakeholders. Each one has different viewpoint. They may have conflict opinions. And this is normal. This is not something someone is right, someone is wrong. This is all of them, they are valid. For example, for the management team, they always has the time and budget constraint. And on the solution part, we have our best practice. We want the system to be flexible, to be more robust. But if we want to build a flexible system, that means more time. It may affect the project timeline. So this time, the architect, the solution team, need to evaluate the pros and cons for each solution. And they need to make a final technical decision. And then they get the management team, business team, and also developers to review and their approval. So everyone on the same page, and then start the implementation. And there are some very rare situations is that architects, the solution team, they foresee a big problem, and they couldn't get approval to take action to prevent it. And then they may leave this project team. Basically, they quit. It happens very rarely, but if this happens, it's a very strong indicator. So indicates a disaster is about to happen. Basically, there's a very high possibility of project failure because the architect, the solution team, technical team lead, they are responsible for the successful implementation of the whole project. If they don't agree with all the others' decision, it may be the project is doomed to fail. That in their opinion. So, and then about the red alert flag. So the last minute change, if it's out of scope, that means the risk mitigation plan failed. For example, if other system function not related with this last minute change started failing after this change, and then we need to take immediate action to roll back the change because we don't have time to troubleshooting. It is already causing some problem. We must roll back immediately. So previously we discussed some simple IT concepts. Now I want to compare this IT last-minute change scenario, the IT risk mitigation plan, with this current liquid situation. So first, this is a last-minute change. We know it's not fully tested. There's some unit testing, but some very simple system integration testing, and for sure no regression testing. It's because the testing time is greatly reduced. And also, it's using a special approval process, so it can be massively used. Because under normal approval process, it takes many years for the testing. So everyone knows the impact. But if I compare the two things, I see a few, actually many red flags. But in this presentation, I'll just talk about two red flags. The first red flag is that the risk mitigation plan failed. The change scope is out of control. Basically, the liquid thing is supposed to about the respiratory disease. So if we are using the IT control, I want to control the scope is only in the certain area. And the effect, even if there's a side effect, it should be in those areas as well. But from what we are seeing now, the side effect is totally not in a single area. The side effect could be in lungs, could be in blood, heart, even brain. So in my IT term, the change scope is already out of control. It already went wrong. And the second red flag is that the key scientist, the expert in the approval panel, they quit. That indicates the architect team, the technical lead team, they don't agree with the management team's decision. And they are seeing this project as a failed project or have a very high potential of failure. This is a very strong indicator because in the normal situations, it's their everyday life. The architect team will see people from different team has different opinion is normal. And that's their job to do the solution, to evaluate the pros and cons to get everyone's approval. But this time, they couldn't get everyone's approval. Actually, they themselves don't approve it. That's the reason they quit. It's a very firm decision. So it's a strong indicator they don't agree with that. So because of the above two red flags and many other not indicated here, because I want to make this video short, I don't want to make a whole book explain all the things, all the analysis. I can draw a conclusion that this thing is too risky, so better stay away from it. And for myself, my decision is that I do not consent. But this is just my own decision. It's just my own opinion. It's at my current level of ignorance. And for the other people, if they need some suggestion or advice, what I want to say, you are the expert in your own certain fields. You can use your expertise, you can use your expert knowledge and common sense to draw your own conclusion and decide what you want to do. It doesn't need to be same as myself or same as other people's. You just do your own analysis and make your own decision. It may be same as other, may be different. So first is that what I described before is just my viewpoint. It's using my experience, using my knowledge, and my current level of ignorance. So everyone has expertise in different areas. So no matter you are a student, at home mom, or worker or professional in different industries, you have your own expertise. You are doing a lot of things many times, so you know the best practice. Then you can use your field knowledge. You can use your common sense. You can calm down and do some analysis. You can compare the liquid situation with your working area situation, the things that you know you are familiar with. We don't need those medical jargons, etc. You can just compare those two, see the similarity, and then you can draw your own conclusion. Basically, you are in charge of your own body, in charge of your own health. So you need to do the analysis, your choice. And then once you decided what to do, and there's no need to argue with other people who don't agree with you. Because you are the expert in your area, and the truth is inside of you. You are using your own experience to draw the conclusion. It's not from some experts outside of you. So no one else has exactly the same experience as you, same level of expertise as you. So they wouldn't fully understand your decision. But for yourself, it's okay. You are confident. You are using your own knowledge. You are using your common sense to draw the conclusion. You know what to do. What's the best for you. So this is the end of this slide. And the last, but this is not least, I want to say that a lot of people already made this I do not consent decision, but they are not making videos to explain their thinking process and about their decision. I know in the IT industry, a lot of people make this I do not consent decision, and many other people in other industries also made the same decision. Yeah, I just want to say this one, I do not consent. A lot of people are doing this. They also make the same decision. And thank you everyone for watching. Yeah, this is the end of the video.